This was Mount St. Helens. It lost about 1,300 feet off of the top. It had a dramatic change to the landscape. But to understand...
For decades, the shattered volcano stood quiet. No one expected another eruption. But nearly 25 years after Mount St. Helens blew its top, rumblings deep within the mountain made it clear that this volcano was coming back to life.
2004 was a fairly quiet year in terms of earthquakes. And then all of a sudden, over a couple-day period, we were in a crisis mode.
September 23rd came, we had an earthquake, and then more earthquakes and dozens of earthquakes. And suddenly, we were having magnitude 2 and 3 earthquakes at a rate of 2 or 3 a minute.
My line of thinking was that it was just going to be a little earthquake swarm and it was going to be over with. And then it just kept going and ramping up from there.
It's entirely possible that this is a continuation of the process that began in the 1980s. This is the next phase.
At the Cascade Volcano Observatory in Vancouver, Washington, scientists were caught by surprise. And the public, along with the media, worried about a repeat of the devastating blast of 1980.
So we expect fluctuations in the level of unrest to continue.
This event in September, I mean, it was an international incident. There were people here from all over. It was obvious that something was punching up behind the old lava dome in the crater floor and fracturing the glacier and so forth.
From what I've been told, these are very small quakes. They're not occurring very often, but clearly things are moving down there and opening pathways up. It doesn't seem to be over.
In fact, live now with Sky, you're seeing Mount St. Helens, Spirit Lake, and there always has been.
The world waited anxiously for something to happen. Then, on October 1st, 2004, a rift opened in the crater. The mountain began to erupt. Ash and steam rose to 12,000 feet. Glaciers buckled and broke apart. This wasn't a big eruption, at least not compared to the blast in 1980. But for science, it was a big deal. The most studied volcano in the United States had come back to life with almost no warning. It was as if everything scientists knew about volcanoes had brought us no closer to prediction.
In some ways, this was almost a phantom type eruption, that we know that lava had to have gotten to shallow levels without our being able to detect it.
The 2004 eruption is a second chance for us. There was no reason to expect that St. Helens would begin to erupt again during our lifetimes.
Scientists had learned enough to know we weren't in for a 1980 repeat, but there were still plenty of unsettling questions. Why did this volcano erupt so suddenly? Why didn't scientists see it coming? What does this mean for other Cascade volcanoes that are, for the moment, quiet?
It was a pretty vigorous burst of steam and ash while we were there.
Every time a volcano performs for us, it gives us a test, and usually poses more questions than we have answers for.
In the Cascades, each peak, each hot spring, each hillside of ancient basalt hints at the invisible volcanic plumbing beneath the surface. These are windows on a volcanic past. They remind us that the Cascades are alive and will erupt again, potentially threatening millions of people in the Northwest. Science is our first line of defense. So with technology and a lot of footwork, scientists are working to better understand how volcanoes work, and they're uncovering a few new mysteries along the way. Today, in a remote wilderness 25 miles west of Bend, Dan Zarishan and a team of researchers are on a mission. They've come to investigate what may be the first rumblings of new volcanic activity.
We're at the Three Sisters Volcanic Center. It's a very active area of volcanism in Central Oregon. It's an area that's been active the last few years, too. There haven't been eruptions, of course, but the ground has been rising at an average rate of about 1.5 inches a year. So something's happening 4 miles under our feet, causing the ground surface to rise. It's been going on since 1998. Right here, and for miles on either side of us. So we'd like to know, of course, what's causing the ground to rise.
Ground deformity is Dan's specialty. He believes the swelling of the Earth's crust around South Sister may be an early warning sign, an indicator of some future eruption. It's the kind of clue scientists wish they had in the 1970s at Mount St. Helens.
Prior to 1980, we didn't have a good way of measuring any ground movements that might have happened before the earthquake started and that big bulge started to form on the north flank of the volcano. By the time we got there, magma was already up inside the volcano, the part you can see at the surface, and was pushing the north flank out. So, of course, that resulted in the catastrophic eruption on May 18, 1980. And I always felt, well, if only we had been there in the 70s, we probably would have seen a broad bulging as that magma accumulated.
Broad bulging is what's happening beneath the Three Sisters right now. This potential warning sign would have gone unnoticed just a few years ago. But now, thanks to something called a radar interferogram, scientists can see what would otherwise be invisible. An interferogram is a satellite scan that shows changes in the landscape over time. In this case, the view is over Three Sisters. The bullseye represents the bulge emerging along the shoulder of South Sister. This was the only clue scientists had that the Earth was moving below Central Oregon.
Shorten point 4.
Dan now conducts annual ground surveys to get a more accurate reading of how much the bulge is growing. And global positioning systems are placed throughout the wilderness, in areas that often fall far from the trail. That job falls to Mike Lisowski.
Working in the wilderness is really difficult because it's physically demanding. There's some people that enjoy that type of work, at least for a while.
60.7.
We know what our target is. There's a bulge and it's centered over there about 2 kilometers away. So we put a number of stations close in, and we try to put other stations farther out than other stations farther out, because we want to document where the deformation is in the area and how fast it's occurring.
The bulge has been hit with at least one earthquake swarm, the kind that signals volcanic unrest. That's not enough to cause concern, yet.
This part of the Cascades has both basaltic eruptions and explosive eruptions, but it's unlikely that there'll be anything like Mount St. Helens in 1980, and I think even an explosive eruption wouldn't cause too much loss of life. You know, it would mess up the wilderness, though.
Scientists keep an eye on the bulge using GPS. By calculating distance between GPS on the ground and satellites in space, they record the swelling of the Earth down to the thousandths of an inch, and in 3 dimensions.
Lengthen 1.7.
The bulge has grown just 8 inches since 1998. As a tourist attraction, it doesn't amount to much.
We do have hikers ask us, where can I go to see the bulge? And they typically ask us that when they're standing on it. And of course you can't see it. An inch a year over 10 miles is you're not going to see.
The bulge gets attention because in all other respects, the Three Sisters wilderness is quiet. But evidence of past eruptions are everywhere.
Something like this may be just how the Cascades stay alive. They get a little plop of magma come up here and it stays there and nothing happens. Or it may be the start of another eruption.
What we don't know, because we've only been here for a short period, is sort of the long-term pattern. Do we just happen to be here in exactly the right place, in exactly the right time, with exactly the right techniques to measure the bulge that's going to come right before the next eruption? Well, it could be. But it could also be that uplifts like this happen all the time over geologic timescales, and that the vast majority of them don't culminate in eruptions.
Eruptions are the exception, but Central Oregon has historically produced more lava than any other spot in the Cascades, and it's still active.
We talk about the Three Sisters Volcanic Center. There's a little bit of a combination here, where there are lots of vents, not big, tall, volcanic peaks that erupt again and again and again, like Mount Baker, Mount St. Helens, Mount Hood. The volcanism is more diffuse, more spread out.
Several active volcanoes around the world bear a striking resemblance to those found in Central Oregon. Eruptions in the Galapagos Islands, where lava oozed from the ground as recently as 2005, are nearly identical to the shield volcano eruptions 1,300 years ago in Newberry Crater south of Bend. The spectacular vent eruptions on Kilauea, which carpet miles of Hawaiian countryside with rivers of lava, are the same forces that buried Mackenzie Pass east of Eugene 1,500 years ago. Eruptions will happen in Oregon again, sometime, somewhere. But the clues that could help predict the next eruption remain frustratingly hard to decipher.
Check.
So let's say a volcano is going to erupt once every 100 years. What we think we've learned is that after 50 years, very little will have changed. As far as we know, after 95 years, very little will have changed. And it might be after 99 years, you still won't be able to, no matter how hard you study that volcano, see anything different from the past 99 years. But at some point, there's a significant departure from what's been happening. Now, at Redoubt Volcano in Alaska, for example, 1989, the volcano had not erupted in 30 years. An earthquake swarm began, intensified. 24 hours later, the volcano erupted explosively. At St. Helens in 1980, that period lasted 2 full months before the catastrophic events of May 18th, when the north flank slid away in a gigantic landslide. So you don't always know how long the warning is going to be, but there's almost always short-term warning. What we don't know here at Sisters is where this uplift fits into that scheme. We're pretty sure it's not short-term warning. It could be intermediate-term warning.
The painstaking study of volcanoes, especially quiet ones, can seem academic. But for scientists, the reality of what happened at Mount St. Helens in 1980 is never far away. Back then, researchers had little more than seismographs, binoculars, and a good pair of boots to help determine when Mount St. Helens would blow. Volcanology was in its infancy. Mount St. Helens was poorly understood.
For 123 years it was dormant, but today the volcano exploded with a powerful force that turned daylight to dark. Tonight, the death toll from the explosion had reached at least 7.
The blast on May 18th exceeded the worst-case predictions of the experts. The devastation that rained down on southern Washington was on view to the world. "57 people died.
The May 18th, 1980 eruption, of course, was catastrophic. And in hindsight, we know a lot more about what happened, why it happened, and how it could have been more directly anticipated than we knew then. Was this an unprecedented event? Turns out it wasn't. Just in a few years after that landslide and explosion, there was tremendous erosion of gullies on the floor of the crater. And down in those gullies, geologists found evidence of at least 2 other landslides and lateral explosions. There's a geologic record in the walls of the crater that we could never access before. So we now know that St. Helens does have this kind of history.
After 1980, the consequences of an eruption were clear to everyone. The public demanded a better understanding of the volcanoes in our backyard. Scientists took the lead and made Mount St. Helens their laboratory.
Here's an image of what we call a digital elevation model. It shows you what the surface looked like soon after the eruption in 1980. You can step through time. Here's 6 years later. You can see that there's been tremendous change in the growth of the dome. Then in 2003, this glacier that's formed back here.
Steve Schilling is a hydrologist with the Cascade Volcano Observatory.
Since then, we've had even a more dramatic change. We're not quite sure of what is driving everything underneath the ground. So we're using these different methods trying to answer what is going on and what can we expect from it.
Many people are surprised to learn that Mount St. Helens is still erupting. It has been since October 2004. Dramatic outbursts of steam and ash can occasionally be seen for hundreds of miles around. But most of the changes taking place are more subtle, visible now thanks to new technology.
The yellows and whites and reds are the hotter colors where the rock is hot.
Heat-sensing cameras capture the drama that's unfolding within the crater. Magma, liquid rock from miles beneath the mountain, oozes onto the surface at over 1,000 degrees Fahrenheit. As the rock cools, a dome grows. Time-lapse photographs show the magma dome approaching 1,000 feet in height and stretching over a half-mile wide. To put it in perspective, if the city of Portland were dropped into the crater, it would be dwarfed by 2 magma domes, one built in the 80s, and the other, the grayish mass in the background, created in just the last year and a half. If dome building continues as it has, Mount St. Helens could reach pre-1980 heights in just 50 years. Few volcanoes in history have ever rebuilt so quickly.
It's not just a garden variety eruption. This one is very strange. The magma that's coming out of the ground is very poor in volcanic gas. It's a little cooler than the lava that came out in the 1980s. It's more crystalline, it's much, much stiffer. It apparently rose up under the lava dome that grew in the 1980s and was deflected, and now it's coming out of the ground at an angle, so it's not piling up on the vent, and we can watch it come out of the ground. That's an opportunity we've never had before. Got a whole new set of questions to ask.
To extract answers from the steaming, bubbling crater, scientists have gotten creative.
This is the GPS antenna. All this is either stainless steel.
Their solution, the spider.
Okay, what we've got in this one is set up to monitor the dome in the back of the crater. We've got our seismic transmitter. We've got 2 tilt meters back in here and 2 axes. The GPS receiver.
This unmanned craft, invented by scientists in Vancouver, Washington, transformed almost overnight the way research is conducted.
We needed to get right up near this growing lava dome, and so we started developing new tools. We took a little bit of the old, a little bit of the new. We took GPS technology, modern radio and computer technology, put them in a package that we could take with a helicopter up to the dome and put it right there.
Spiders get their name from the spindly legs beneath each unit. They're slung in by helicopter and are dropped into the most dangerous regions of the new and crumbly dome. This is territory scientists would rather not explore on foot. But spiders can be left unattended for weeks, or at least until things get rough.
This is one of the spider carcasses that came back, and it broke the steel legs off. It just crushed and tore off the half of this container and shattered the inside contents. You can also see that it was very hot. We've got rocks that are actually melted into the plastic, and most of the protection on the cable is actually burned off. So the heat and the crushing blow really drives home the fact that this is not a place where we want to have people.
With the spider, Rick Lahusen says scientists can get an up-close look at unusual but unstable features, like a glacier that manages to share space with a red-hot dome.
This glacier was about 600 feet deep in the back of the crater, so there's a large volume of water available. As this hot rock material is coming up, it's melting. These pools of water essentially could rapidly hit the hot rock and form some significant explosions. And there's really no indication of when that's going to happen, so it's kind of a surprise event.
We know that we have this mass of lava that's, relatively cool on the outside. Inside, we know that it's probably 600-700 degrees Celsius, and right next to this is a wall of ice.
Scientists roll the dice every time they descend onto the surface to gather rocks or sample gases. So for the most part, they're happy to let spiders do the work.
What we had in the 80s, when it was a good weather day and you could fly,
and you could be out in the crater. You could make some measurements during the core of the day. This eruption started just as we're heading into fall, winter. So that's a time period where you can't be out there as much. You just can't access the site. The nights are long, and these guys are on the job 24 hours a day. So we have a continuous record.
The flip side of technology is that scientists have to digest the cascade of raw information pouring in. Even from their desks now, scientists are hardwired to the mountain.
So these are the real-time data. Here's an earthquake coming through right now in real time from the two spiders out in the crater. When our beeper goes off, and Murphy's Law says it'll be Saturday night at 3 a.m., in the middle of a storm, you can pop up your screen, turn the thing on, and you can look at the deformation, you can look at the seismic information, and you can make an assessment. Having this communication capabilities, both the wireless cell phones, pagers, and things like that, and having the high-speed internet available that we can analyze the data in real time and then communicate it out is a huge difference from 1980.
Mount St. Helens is easily the most wired volcano in the world. When it woke up in 2004, access to the mountain's vital signs allowed scientists to predict, accurately, that this eruption would be nothing like 1980. The public could witness this eruption without fearing for their lives. But scientists know much less about other Cascade volcanoes. Mount Hood, Mount Jefferson, Mount Rainier. Any of these could be next. Yet we know little more about these volcanoes than we did about Mount St. Helens prior to 1980.
What we learned from experience is it's difficult to play catch-up with a volcano. And we worry about, for example, a period of intense unrest starting at Mount Rainier in February. There's not much you can do at Mount Rainier in February. If you don't already have the instruments in the preceding summer, there's not a lot more you can do in the middle of winter.
It is probable tonight Spirit Lake is no more. Huge pyroclastic flows of hot ash, rock, and gas have enveloped the lake, turning it into a bubbling cauldron of hot debris.
25 years after Mount St. Helens showed us how destructive volcanoes can be, scientists still dream of the big breakthrough, the one that could help them predict the next disaster.
If we could say now that the next volcano to erupt in the Cascades was going to be that one, because we see something that tells us that it's closer to its short-term period of unrest than all the others, that would be extremely valuable. You probably wouldn't build big subdivisions around that volcano in threatened valleys, for example, if you had some way of knowing that within, say, the next decade, something could happen.
The questions are the same as they've been for centuries. What makes volcanoes tick? What fuels the process? Scientists still struggle for the answers.
At a rate of 5 feet per day. And they looked at
I hope that the public doesn't think we know everything there is to know about volcanoes. We don't. We're on the steep part of the learning curve, if you will. Volcanology is still a relatively immature science.
For those who live in the Northwest, Mount St. Helens remains a daily wonder. The bulge beneath South Sister is still a mystery. Maybe they fascinate us because there are forces at work that we still don't understand. Yet each day, scientists scratch the earth for clues. Each night, they crunch numbers and analyze data, hoping to one day unravel the secrets of the Cascades.
It looks like you just powered up the gas monitor, is that correct?
I think a lot of us were really fortunate to have one eruption in our career, and now to have a second one is really great. And it's also giving a new generation of folks experience.
We've learned a tremendous amount just in my short career, but there's so much we don't understand. It's such a rich subject that there's work to be done for generations to come.